All right, so let's get started. The way I like to talk about this with, well, techies and non-techies, just show of hands, how many people here would consider themselves as like a geek, a nerd, programmer, dev, techie, something? Okay, great. So the way I'd like to talk about this to really, set some context is that I think the last 50 years in technology have really been about two fundamental scarcities. Oh, this is really, can you guys see that at all? Sort of? Yeah. Okay. So the first is what I call the PC revolution, where we got the PC that came around in like the 70s, and the problem with the PC is that it's the hardware got cheaper and commoditized. The software was it became more and more difficult. So computers ultimately needed code, and writing code is hard, and a very tiny percentage of the population can actually do it, can think in the ways to be able to write code effectively, build apps, have the patience to debug them, and so on and so forth. So there's scarcity there of coding talent. And then on the right-hand side, the internet revolution, what really, the fundamental scarcity there was that bandwidth is scarce, and latency is high relative to the information space of what we want to query, right? And what's interesting with the AI sort of revolution that's happening, LLMs being kind of the first drop of hinting at something very, very big as possible, it sort of addresses both of these. It at least makes significant inroads in these in a fundamental way. You can now query information systems. You have models that fit on a USB stick that take out your bandwidth problem. You can have local models that contain a lot of information. Some of it might be fake, but it contains a lot. It contains the ability to answer a tremendous amount of questions in a really shocking way, and it fits on a USB stick. And then with the PC revolution and the code skills as a scarcity, that's also being resolved with code generation, right? So that then really puts this in context, in that right now, if you were to go and sum up the entire grand total of Homo sapiens, like what percentage of the population can actually do anything technical, write a line of code, write a SQL query, plug in a server, rack a network switch, anything remotely technical that we consider in the industry IT, okay, that is about 4% of the population. It's sort of the kind of math we generally don't do very much if we live and swim in a technical ecosystem. We're on GitHub every day. We're talking to a lot of other coder nerds on Slack or Discord or whatever. You don't think about it, but when you actually say how many bodies, how many humans can actually code, it's 4%. And that kind of computer literacy, if that were something else, if that were like the ability to read and write, if that were the ability to do math, if it was literacy or numeracy, we would consider that shockingly low, right? But when it comes to computers and being able to make computers do things, we're like, okay, well, that's just the IT industry. If I need an app written, I'll have somebody do it. If I need a database configured, I'll have someone do it, But what AI would allow us to do is allows us to turn on this capability for the other 96% of the population. They can then start actually creating with computers the way that we as geeks can create with computers. They actually can probably do it even better as technology improves. So this is like a really amazing thing, and that's why I want to anchor how important this is. This isn't just about another turn of the technology crank. Can we go and flip another few billion-dollar businesses or whatever else? This is something transformational, fundamental. And that's why you have things like Sam Altman saying, I'm going to do a $500 billion project. That's a lot of money. Like $500 billion, I don't know about y'all, but like that's actually a lot of money. And to have the audacity to pitch these kinds of things, it's only real because the potential is so large, right? And when you look at the amount of dollars that people are actually spending, not just pitching, but spending to train the models, to build the data centers, it's absolutely massive. $100 million, $200 million to build one of these cutting edge models. But I still think we're very much in like the Wright Flyer days. We're so much still, even though we're 2.5 years after the ChatGPT moment, we are still very much at the very dawn of the age of flight, if you will. And in fact, when you go and you do things like asking an LLM to count the number of letters in a word, you realize we're not even at the airplane stage. We're at the Zeppelin stage of flight, right? You technically have heavier than air flight, but that's the kind of stage we're at. And we'll eventually invent the aileron, the propeller, and things like that. But that's kind of where we're at. And it's also really important to ground our thinking in what's really going on. The heart of the transformer, which is what all the LLMs use, it is about 80 lines of NumPy code. This is not some, when people talk about, oh, we need a Manhattan Project for AI. Well, I mean, it's 80 lines of, 80 lines of NumPy. And that's just for LLMs, and that's for transformers. And you have people like Yang LeCun saying, LLMs, dead end. Like, don't even talk to me about autoaggressive LLMs. So, so this is, and the reason he's saying things like that is because we have a lot of new and interesting research coming out that are showing that there's a lot of frontier space still available. I personally think we have at least 100x improvement available on some figure of merit, right? Take latency times, throughput times the amount of space times fidelity, whatever, some kind of intuitive figure of merit for a quote-unquote AI system. I think we have 100x available ahead of us. And a lot of interesting research, whether it's things like BitNet and 1.5-bit quantization, or whether it's things like Microsoft building a model based entirely on textbooks, right? Or these other kinds of, mixture of experts, chain of thought, all these different kinds of things. Whether or not these are AGI, that's not a question that I want to talk about, but just at the very basic level, the current research in the trenches indicates that there are a lot of interesting algorithmic improvements available. And there's even deeper questions about what the LLMs actually are and what we're actually doing with all this data that really start, they start raising interesting questions. Because like, okay, it's one thing to say I need 500, where's Sam? I need $500 billion, but if 100x improvement is possible, maybe it's only 5 billion. So you're going to go and mark that down by 100x? What are we doing here really, right? Same thing with these models. Training frontier models, are they really that much better than the second or third place models? And how much are you going to recoup that particular moat? So I think the reason why we as individual technologists and we as, I guess, users, we as makers and hackers and tinkerers, we should have very, very clear thinking about what's really happening here and what's really at the heart of all of this stuff. And at the heart of it is all of the data, right? At the end of the day, the data sets, the embeddings are fundamental. This is from a blog post from a Google researcher that said, the it in AI models is the data set. That ultimately we may talk about a llama model or a ChatGPT or something, but the models don't really matter too much. The training data is really all that's projected into or compressed into or whatever the data set. So one really interesting result that's come out in the last kind of year and a half or so is this idea that these large models, the really large models that consume so much data, they're converging on something like a universal encoding. And this is called the Platonic representation hypothesis. And it says that whatever large data set you may have, whatever set of books you may have chosen, whatever part of the internet you scraped, if you're building a model at a certain class, at a certain size, oh yeah, I really just can't see that at all, right? It's the paper here is the universality of neural encodings and CNNs, and over here is the Platonic representation hypothesis. Those are really, really interesting papers, and the Platonic representation hypothesis basically just speaks to the idea that with these large models, at the end of the day, even if they have slightly different data sets, they're actually going to converge mostly on having the same representations in the embedding vectors. And more importantly, just recently, some work coming out of like Cornell Tech and whatnot, they've demonstrated that you can just take these embedding vectors, you can take these encodings, a large opaque matrix of numbers, and you can build a translation to another model, and you can basically translate things back and forth. So they demonstrate this with a particular interesting thing where there's an opaque open weights, but still you don't know what data went into it kind of embedding model. And then on the right-hand side, they've created a model that used data set that they did have access to. And by looking at, by having that, they can build a translation to this one because it's still, one is essentially a rotation of the other. And then what they can start doing is they can start attacking and pulling data out of the opaque embedding model. They can start pulling PII and other things from its original training corpus out of it. Because these models at scale are all kind of the same model, right? A really shocking thing. And the implication of the universal encodings thing is it suggests that the biggest and the most expensive and the largest models are converging to the same weights within some hyperdimensional rotation matrix of each other. And that would mean that the bigger the model is, the more commoditized it is. If you guys want to get to the roots of, like the intellectual roots and the philosophical roots of intellectual property, there's a really interesting thing that you can make the argument, because so much of this data is actually commons data, public data, that the information contained within these models is actually cannot be treated as proprietary, cannot be treated as property. Wouldn't that be hilarious? If you were to tell Google or Microsoft or OpenAI, the bigger your model, the more it asymptotically approaches a commons and non-proprietary artifact, right? The smaller the model, the more differentiated, the more different a view of the information world you might have, the more it can be rendered proprietary. But the bigger the thing is, the more it converges to sort of like the grand central limit Platonic representation of all human knowledge, which is the birthright of humanity, right? No one owns the concept of table. No one owns all the digits of pi. You might have a very clever way of deriving the 500 billionth digit or trillionth digit of pi, but once you discover that digit is 8 or 2, that knowledge itself is not yours to own, right? Because it's pi, it's everyone's. Everyone gets to have pi, right? So, so this then, but this doesn't, this particular argument, it's a fun nerd argument. I think it's a really important one that hopefully we'll see more and more ramifications thereof. But at the end of the day, what all the companies are doing right now is they're taking the standard Silicon Valley approach, which is, you know what, data is the new oil, or data is the new uranium. We need to build a moat around our data. We'll hoover everything up. We'll have our own internal ways of cleaning it, of processing it, and we're going to make these big models, and that's going to be our edge. That's going to be our moat. And what this has created is it's created actually a crisis in the open internet and the open information approach that the internet really put on the, gave us, really. It sort of pioneered that. All of us here have been living for decades now, and we're all benefactors of that kind of openness. And what's happening is now that openness is disappearing because it is being commercially exploited. It is being exploited in a very bad way. A lot of places are talking about, actually I was on a call yesterday with some people from libraries and whatnot, where their infrastructure is melting down because everyone wants to scrape their own data. So they're getting DOS with these data scraping sort of things. And furthermore, so many people that were used to setting up websites and sharing information because it was human eyeballs on the other side of the web browser, they're now starting to put gates down so that archivers like the Internet Archive, people like Common Crawl who are trying to make data sets available for linguistic research, all these folks are getting shut out. And so this wonderful paper is called The Consent in Crisis, The Rapid Decline of the AI Data Commons. And I'll just read a couple of these things for you. Their conclusions were, number one, there's a huge proliferation of restrictions now on the AI data commons. There's a rapid proliferation of restrictions on web crawlers. In 1 year, 2023 to 2024, so the year of 2023, about 25% of the tokens from the most critical domains have become restricted. And so we're going to see a dramatic decline in the amount of open data available for everyone. There's consent asymmetries and inconsistencies, right? So people will put things to block OpenAI a lot, but they don't block other people. Or in the case of like Common Crawl, what they find is that people, because of the way robots.txt works, Common Crawl will respect robots.txt. But because people know that if they shut down all web crawling, they won't get indexed by Google, they will allow Google to come in and index them, but only Google gets to index them. Everyone else gets shut out. And this is a winner-take-all Matthew effect, right? These are the kinds of things that we're seeing. And then what this leads to as well is a sort of a sorting pattern where the content characteristics between the head and the tail of public web crawled training data is very, very different. So a lot of the user content that is the most valuable, multimodal kind of content, things like that, there's those things have a different fate than encyclopedias and news and other things that become monetizable. So like the most high salience and the most highly refined, highly curated data becomes shut down more out of these commons data sets. And the slop, just random people recording themselves, jumping over a dumpster or something, those things start filling the internet, right? Those are freely available. So anyway, without getting too much into that, at the end of the day, you have comments like this, where this is from literally from The Verge in September after the Llama model release. And people are starting to sue about this sort of thing. So they interviewed Mark Zuckerberg, and he literally said, quote, individual creators and publishers tend to overestimate the value of their specific content in the grand scheme of this. My guess is that there are going to be certain partnerships that get made when the content's really important and valuable. And if creators are concerned or object, when push comes to shove, if they demand that we don't use their content, then we won't use their content. It's not like it's going to change the outcome of this stuff that much, right? TLDR, go ahead and opt out. Your data doesn't really matter anyway because they're going to get so much of everyone else's. And they have such a dominant effect. They're going to drive partnerships with everyone else producing interesting data. So that's sort of the view from within the trillion-dollar moat builders. And if you were to escape some of that, if you read a lot of AI Twitter and if you're on a lot of stuff, there's a huge amount of this great man theory in Silicon Valley. There's been very, since the start of the centralization of the internet and the build out of these trillion-dollar internet companies, there's been an unapologetic sort of philosophy around the man in the arena or the great man and all these things. And not enough voice is given to the reality on the ground, which is democratized innovation and crowdsourced innovation. I had a former Microsoft, I wouldn't say executive, middle manager I talked to at one point. And his perspective was, oh yeah, at Microsoft, everyone knew that open source is really great at solving well-known problems, well-understood problems. And that was the perspective from within those kinds of entities. Whereas my experience in places like Python and PyData is we know that actually open source, crowdsourcing, open innovation, this kind of hacker commons and hacker mentality, that kind of collaboration is the way that you build out a lot of things in parallel, and you build quickly, and you're able to explore all the interesting niches. It's a vastly more capital efficient way to explore the art of the possible. And that's why modern AI isn't built on a lot of proprietary, it's not built on proprietary languages, proprietary libraries. There are trillion-dollar companies out there, companies that make billions of dollars a year. They did not build the foundations for this stuff. Modern AI is built on top of things like open source NumPy and all these kinds of things, right? Even PyTorch came from Torch Lua, which came from things like Theano and Caffe, which were grad school projects, right? So and those grad school students were informed by collaboration with a lot of other people around the world. So we all know, and I hope many people who are at an event like this, in a venue like this, understand and appreciate that there's a whole different untold story about how technical innovation can happen, how it actually has happened. We just don't talk about it. It's the thing that everyone who wants to go and prop up a great man as their next, VC wonderkind, those people don't want to tell the story. But this is the story that I feel like I have to tell because I lived through a lot of this. And it's also, I understand the logical conclusions if we don't tell the story, is that everyone in the world is just going to believe that they get to either vote for Sam or go vote for Mark or vote for Xi Jinping or vote for whoever. And it's just going to be one person or a small set of centralized entities that control the future of probably the most important and innovative, most important technology that we'll see in the next few decades, right? So the thing that I want to really put at least words to is this idea that open source communities are not just nerds on a mailing list, right? They're actually human ecologies. And I want you all to really think about that term, human ecology, center on that, because it is a way of collaborating, it is a way of being, and it has its own values. Those values are about participation, giving you stake, right? You're not just taking free stuff. Is it free beer or free speech? It's not really either. It's a free interchange of ideas, right? That is actually the kind of thing that made the free software and the open source movements very successful. Participation gives you voice. It preserves your agency. If you just show up, I don't care if you're some random consultant who's like, hey, I'm using this open source project. I need you to fix this for me. And then if you're the open source maintainer, you're like, why? Like, who are you, right? You could be a random schmo consultant driving up. You could also be Jensen Huang with like NVIDIA saying, I need these changes made to this project. And again, in the ethos and in the value system, in the human ecology of an open source project, the maintainers are well within their rights to say, why? That doesn't fit with how we do this project. That doesn't fit with what our vision is for this project, right? So it's really a deeply human and individual relationship-based thing, not a company and brand-based thing. And I see that myself very much as I engage in the Python community with other people that I've known for a long time. I mean, I show up with an Anaconda shirt and an Anaconda hat, but people also know when they're talking to Peter, right? There's a very big difference actually in those things, and it's fine. But one of the really powerful things about open source is that it is a way of leveraging software that doesn't conform to the classic intellectual property approach. And this is going to be really important when we get to the second section when I talk about data and the future of how we can maybe lock innovation open for AI. So most of you here, how many people have made an open source project or contributed an open source project? Okay, good number of people. When you contribute to an open source project, you know there's probably a license.txt or a license.md file, right, in your repo. And that license is really important. You know, you get to choose, do I want to use a BSD, MIT, Apache license? Do I want to use GPL, LGPL, whatever it might be, many different licenses available. All those licenses, however, still sit within a copyright regime because software is copyrightable. Under American law and then under the Berne Convention, software is a piece of intellectual property. Legally, it is copyrightable. If you write a piece of software, it's yours, unless you've assigned it to your employer via maybe like employment assignment agreement, unless you assigned it to someone who's paying you to do this work, right? So software became property, and that was a thing that had to happen. That's not a thing that naturally exists in the world. There was a lot of debate about this, right? About software is just numbers. When people were making money selling mainframes for tens of millions of dollars, the code was just like an instruction manual. How could you, the instruction manual for your washing machine, for your car, that's sort of like a freebie. You give it with the car. But what started and created the software revolution, starting at the dawn of the PC era in 1976, the Copyright Act of 1976 formally established that software is a kind of intellectual property. It is copyrightable. And in doing that, it made it into property. It made it something that people could buy and sell and could invest in. But open source human ecologies treat software as unproperty, a really radically different concept. None of us have any intuitive understanding in the physical world of unproperty. It doesn't exist. There's no apple which, if you take a bite of it, a second one emerges for you to give to your friend. There's no house in which you buy the house, you move into it, and more house appears. Or if I have a can of beer and I drink it, and there's more beer to share. We do not have this kind of dynamic, right? And Thomas Jefferson famously said about intellectual property and ideas, right? When I light another candle, it doesn't reduce my flame. Or if I use whatever, I'm completely butchering it, but you all know what I'm talking about, right? The idea here is that when we share the ideas in software and via software, it does not intrinsically have to be limited in this proprietary fashion. And open source as a concept, open source communities as lived human ecologies, they demonstrate a thriving, abundant, regenerative dynamic that is based on unproperty. The more you share, the more valuable it becomes. The more you cut it down, the more you fork it, the more you close it down, the less valuable it becomes. It's completely the opposite of everything we are interacting with in the physical world, because the physical world is almost completely defined by scarcity, right? So the abundance mentality that it takes in order to succeed and thrive in this kind of human ecology, that abundance mentality sort of disappears when you start taking a scarcity mindset view and all this stuff. So from all of that is to say, and this is again, the first kind of half of the talk is to sort of motivate how I'm thinking about what the AI transformation revolution could look like if we move to a different point of view than the great man in the arena, and we've all got to be rooting for like this guy or that guy. Usually a guy, it turns out. So the question is, what does it look like to do democratized AI for all? Like, what does it even mean? If these big models are actually non-property, they can't be made proprietary because they're essentially platonic, or they're asymptotically approaching a platonic artifact that should be the free and natural birthright of all humanity. How do we get there? If that's actually true, if we can do that, like what does that look like? Because there's companies selling for tens of billions of dollars, making billions of dollars in revenue on the basis of an entirely opposite model to that. And I would just call out for folks to think about back in the early days of the Industrial Revolution here in the United States, Railroads, they owned their own railroads, right? Railroad companies, they owned the railroads. They paid people to go and cut through forests, to blow up channels through mountains and carve passes, and they would run the railroad, and they owned that railroad. And it made sense. It was a huge expenditure to go and lay a railroad across thousands of miles of the land. And then they would have the rights on the railroad, they'd run their trains on it, and they had total control over those railroads. But it's actually kind of inefficient because everyone has to build, if you want to compete, you got to build a different railroad. If you don't like how that one railroad operates, you got to build a different railroad. Versus what we have today with road networks, where we have a common shared infrastructure of the road network. You don't have the Toyota highway or the Ford highway or the Nissan highway. We just have the highway. We just have 24th Street, and it's not owned by Chevy or Tesla or anybody else. We just drive on this road, we maintain the road, and that's way more efficient. This is the idea, a very simple concept of the commons. And we did move from private railroad companies owning railroads to a common, state-maintained community infrastructure that is shared by everyone. But to do that, we had to move from trains to cars, right? There was some technological changes that had to happen. But ultimately, this just drive home the point that these kinds of changes have happened in the history of humanity, and even just here in the last 150 years in the United States. So it's worth thinking about, it's worth pushing for the idea of what can we build in a commons way? What can we do that actually locks innovation open for everyone? So, because that's not what the railroads did, right? You could not innovate on the railroads because one person owned the railroad. It might have benefited them to have the service be exactly the way it was. Innovation is locked down because the substrate for innovation